Welcome back, students. Today we'll be covering some more questions on statistical description of data. And I am CA Pravesh Agi, your mentor for this lecture. So let's start with this question. Question number 23. The weight of 50 students in pounds are given below. So these are the weights, 82, 95, and there are about 50 students. The weight of all these 50 students in pounds is given in the data. So this is the data. If the data are arranged in the form of a frequency distribution with class intervals of as 8100, 100-120, these are the class intervals, 120-140, 140-160, and 160-180, then what we are required to find out the frequencies for these 5 class intervals. So this is the question. So let's answer it. So we will look at this answer now. So what we'll do, we will try to find out how many students are there between 81 to 100. And when we look at, we find that there are, we'll just put telemarks. So if you look at the telemarks, we'll get almost 12 entries in this. So there are 12 data entries which are falling in this. So altogether, there are 12 students which are coming in this class interval. Similarly, for 101, 120, if you look at the data, then we'll find that there are 11 students who are falling. So we first look at those data and make a telemark after seeing individual entries which fit into. So I'm just skipping that. I'm just simply, this you can do yourself. So there are 11 students which are coming in this class interval. Similarly, in 121 to 140, we look at the individual data and find out how many entries fall under this. So we find that there are 6 students, which are number of students who fall under this weight category. And then from 141 to 160, there are 9 students. So we look at the data, and this is 5. Then there are another 4 which fall under this. So altogether, there are 9 students which come under this class interval, which whose weights are between 140 and 160. So that then we look at the data and see how many students are coming in under the weight 161 and 80. And we found that there are 12 students. So we will make a tally bar of this. So this represents 10, and there are 2 more in this. So altogether, there are 12 students which are coming under this. So now we have tabulated the data, and we have put the class intervals. And in respect of that, we have the number of frequencies or number of the students falling under this weight category. So, so this solves our problem. So all this data has been tabulated, and we were required to find out the frequencies of the 5, 1, 2, 3, 4, 5 class intervals. The frequencies. So the frequencies are 12, 11, 6, 9, and 12. So let's start with another question. The question number 24. So the question number 24 says that the following data relates to the marks of 48 students in statistics. And these are the marks of the 48 students which are given. Okay, these are the marks. What are the frequency densities for class intervals between 30 to 39, 40 to 49, and 50 to 59? So this question says that we have to find the frequency density. So first of all, we should know what is the frequency density, and then we'll find that what are the frequency density for these class intervals. So let's solve this. Now we'll tabulate the data. So we have to find the the frequency densities for these classes intervals. Now frequency density of a class interval, it may be defined as the ratio of the frequency of that class interval to the corresponding class length. So let's first find out the frequency. We are required to find it for 30, 39, 40, 49, and 50, 59. So we are required to find the frequency densities for these very classes as per the question. So we look at the data and find out what is the frequency, how many students are there, or how many students are there who fall under this class interval. So looking at the data, we find there are 9 students who fall under the category, under the class interval 30-39. And similarly, between 40-49, we found there are 11 students who are coming in this This is after looking at the data and then finding how many students are coming within this class interval, and we found that 8 for this. So a frequency density then would be 9 divided by the class size, that is 10. Between 30 and 39 there are 10 students, so the frequency density would be 0.90. And then between 40 to 49 there will be 11 and divided by 10, so there will be 1.10. And between 50 to 59 we find there are 8, so 8 divided by 10, so it will work out to 0.80. So that means the answer is this. The frequency densities for the corresponding class 30-39 is 0.90, and the frequency density for the class interval 40 to 49 is 1.10, and between 50 to 59 it is 0.80. So that solves our question. So let's move on to the next question. So we move on to the question number 25. So the question says, following information relates to the age of death of 50 persons in the area. So these are the age of death. Okay. If the class intervals are 31 to 33, 34 to 36, 37 to 39, then what are the percentage frequencies for the last 5 class intervals? So we will now solve this question. So though the class frequencies are starting from 31 to 33, 34 to 36, so this is given, 37 to 39, and then we can plot the rest one also. So these are all the class intervals. Now what we are required to do, the last 5 class intervals, that means 1, 2, 3, 4, 5. So we only be focused on this. So now we look at the data and try to find how many number of students are between this class interval. And looking at the data, find there are 9 here. There are 9 here also. And between 50 to 54, there are 5 students, or 5 this thing. And then 55 to 57, there are 1. And then between 50 to 60, there are 2. So so this is basically not students, but these are only persons. So there is a correction here. So we find this. So now we can find the percentage of the frequency. We'll take the frequency divided by the total number of data size. Data size is 50%. So we will do 9 divided by 50 into 100. So we'll to find out the percentage. So this comes to 18%. Similarly, we can find for this also. This will also come 9 divided by 50 into 100. So this will be also 18%. Then this is 5 divided by 50 into 100. So we find there about 10%. And then 1 divided by 50, because 50 number of persons, so we'll take the whole data sample into 100, and we'll get 2%. And altogether there are 50. Only we have collected data only for this, because the rest would be, when we count, it will be 50. The sample size is 50. So the last also we can find 2 divided by 50 into 100, which will be 4%. So as per question, we were supposed to find that what are the percentage frequencies for the last 5 class intervals. So the last 5 intervals are this 1, 2, 3, 4, and 5. And respective percentage frequencies for this class would be 18%, 18%, 10%, 2%, and 4%. So now we will be attempting the question number 26. The table below shows the height of children in a class. Calculate the frequency density. Now these are the heights of the children which are given. Between 65 to 75 centimeters, there are 2 children. Between 75 to 80 centimeters, there are 7 such children. Between 80 to 90, there are 21 children. Between 90 to 105 centimeters, there are 15 children. Between 105 to 110, there are 12 children. Now, this is the data, and we have to find the frequency density. So let's find. So we'll put the data like this. So between 60 to 75, we know that there are 2 children. And the class width is the difference between 65 and 75, so it is 10. So the frequency density would be then 2 divided by 10. That means this number divided by frequency divided by the class width. So we will get 0.5. Similarly, we can find that between 75 to 80, there are 7 students. And the class width is only 5. So it will be 7 divided by 5. This will be 1.4. Remember, the class widths are not uniform. So it is, here it was 10, here it is 5. So between 80 to 90, there are 21 students. And the class width is 10. That is between 80 to 90. So then the class density will be 21 divided by 10. So it will be 2.1. Similarly, we can find the frequency density for this class, 90 and 105. So there are 15 students. And the class width is 15 here. That is 105 minus 90. So it will be 15 divided by 15. So it will come to 1. Then for the last one, between 105 and 110, there are 12 frequencies. And the class width is 5. That is 110. Between 110 and 105, the class width is 5. So it will be 12 divided by 5. So we get the answer as 2.4. And remember, the formula for calculating the frequency density is the frequency divided by the class width or length. So this is the, using this formula, we get the frequency density and we solve the problem like this. Now, let's understand this question. Frequency density corresponding to a class interval is a ratio of class frequency to the total frequency, class frequency to the class length to the class frequency to the cumulative frequency. Now, we just solve the problem and we found we can now pick up the right answer. The right answer will be the class frequency to the class length. If you remember, we did a question earlier and the formula was frequency of the divided by the class width or length. So this is the right choice for our question. Okay, so let's do question number 28. The following sample data set lists the number of minutes 50 internet subscribers spent on the internet during their most recent session. So this is a simple data. So there are a number of minutes 50 internet subscriber has spent on the use of internet. Construct a frequency distribution that has 7 classes. Now this is the data. So this is the 50 internet users who have spent so many minutes browsing the internet. So what we have to do, we have to construct a frequency distribution that has 7 classes. So let's answer it. So now we know that the number of classes are 7, which is stated in the problem itself. Now the minimum data entry, if you look at the data entries, how many minutes the subscriber spent, we'll find that the minimum data entry is 7 and the maximum data entry is 88. So a person has spent almost 88 minutes. So the range then would be, so the range is is 81. That means 88 minus 7. So the range of time spent on the internet is 81. So what we'll do, we'll divide the range by number of classes. Now, number of classes we know is 7. So what we'll do, this is the step number 1 we looked at, and then we looked at this. So third would be, we will divide the range by the number of classes, and then round up. To find the class width. So ultimate objective is to find the class width so that we can make a frequency distribution. And then we found that the class width is the range, that is 88 minus 7 divided by this 7, which is the number of classes. So we find it is 11.57. So this can be rounded off to 12. So now we can construct our data. So we know that the minimum entry is 7. So we'll take 7, and then we are going to add 12 to this. 7 plus 12, 9. So which we found that the class width should be 12. So we are just going to add 12 to this. So we have the upper class limit as this. Then we will take this class and minus 1 and put it here. So this will be 18. Similarly, 31 minus 1, 30. So now this way we have constructed our class sizes, class intervals. Okay. Now we will look at the data and find out how many people fall under each class interval. And when we look at the data, we find there are 6 people who have browsed the internet for between 7 to 18 minutes. They were remaining online. So this is 5 and 1, 6. And for the next it is 10. So we will look at each data and then make a tally mark and fill this up. So this is 10. And then we'll do it for 31 and 42. So here when we count, we found there are 13. So 10 will represent this, and then there are 3 more within this category. So there are 13 number of subscribers actually who have browsed the net between 31 to 42 minutes. Then between 43 to 54 minutes. When we look at the data, we'll find there are 8 such subscribers. And then we found that this is between 55 to 66, there are 5. And between 67 to 78, there were 6 subscribers. And between 79 to 90, there are only 2 subscribers who have browsed the net for 79 to 90 minutes. So there are 2. So altogether, when we total up, we get the count for all the 50 subscribers. So there are 50 subscribers who have used the net, for these very minutes. And so this is what we are required to do. We are required to make a frequency distribution for internet usage in minutes. So that solves our question. So now let's do another question. Now we look at the same data which we just calculated. So using the frequency distribution given below, find the midpoint, relative frequency, and the cumulative frequency for each class, and identify if there is any pattern. So when we make a data, we just try to find out what pattern or what is our analysis of the data. So we'll try to find out the class midpoint, the relative frequency, the cumulative frequency for each class, and then we try to find out an inference or any pattern which the data is showing. So the data is same for the last question which we did. So class intervals are between 7 to 18, 19, all this data is there, and number of subscribers which we picked up from the same information which we just calculated in our last question. So let's now solve this. So Frequency we will make this table. So we have between 7 to 8, this is the frequency. So we have to find the midpoint. So midpoint will be the lower class, this thing, and the upper class interval. So we will just add them up and divide by 2. So when we solve it, it will come to 12.5. So this is the midpoint. Now remember, why we calculate midpoint? Because whenever we make a frequency histogram, or then we require the midpoints. Okay. So midpoint, basically why we do it? For making histograms. If you have to put this data in a pictorial or a graph presentation. So we can do it for the next class interval. So this is 19 and 30. So 19 plus 30. So that is 49 divided by 49 divided by 2. So which comes to 25.5. So similarly, this will be 31 plus 42. And then we'll be dividing this by 2. So we get 36.5. Similarly, between 43 and 54, we have to first add them up and to find out the midpoint. 43 plus 54 divided by 2. So we get, so these are all divided. So this is 48.5. Similarly, between 55 to 66, what is the midpoint? So it will be 55 plus 66 divided by 2. So we get 60.5. Then we can do for this between 67 to 78. So we take 67 plus 78 and divide by this by 2. So we get 72.5. This will be 79 plus 90 divided by 2. So we get 84.5. So these are the midpoints. And generally the midpoints, as I told earlier, they are used for making a histogram, and which gives a beautiful representation of tabular data into a graphical representation form. So now we come to the relative frequency. Now relative frequency would be 6 divided by 50. So the formula for calculating relative frequency is 6 divided by 50. So this will be 0.12. So here it will be 10 divided by 50. So what we do, we take the frequency and take the total frequency. So 10 divided by 50. So we get 0.2. Usually we can make a relative frequency chart or ogive from this information. So this is 13 divided by 50. So this is 0.26. This is 8 divided by 50. So this is 0.16. This is 5 divided by 50. So which is 0.1. This is 6 divided by 50, which is 0.12. This is 2, that is the frequency, divided by 50. So this is 0.04. So let's check. It is 6 divided by 50. This is 10 divided by 50. This is 13, which is the frequency divided by 15. Then we took the 8 as a frequency divided by the total sample, 50. Then we look at the frequency 5 and divide the sample size, which is 50. So perfectly right. So these are the relative frequencies. And now these relative frequencies are very important whenever we are making a relative frequency curve or an ogive chart, which is again a graphical representation of the tabular data. So then we can make a cumulative frequency also. So cumulative frequency is 6 plus 6 plus 10, which is this number, so which comes to 16. Then 13, so it will be 16 plus 13, so which is 29. Then we have 8, so it will be 29 plus 8, so which is 37. So this will be 37 plus 5, which is 42. Then this will be 42 plus 6, so it will be 48. 48 plus 2, which comes to 50. So now what is the interpretation? Now there are several patterns in the data set, but for one distinct instance, the most common time spent that users spent online was between 31 to 42. So there are maximum frequency or maximum data internet users are coming in this category. So there, though I'll write this interpretation, of course there are several patterns which we can identify. But one of the important pattern which we notice that is that, so in the data set, I'll just write this. The most common time spent span that users spent online was between 31 to 42 minutes. So it was between 31 to 42 minutes. So this data is very important to find out that how many people use the data and which is the most popular surfing time on the internet. So normally people use between half an hour to 45 minutes or between 42 minutes. So that has the maximum frequency. So that is the inference from this data. So now we have just put the data back into a more graphical, more presentable form. So if you look at, so this is the frequency distribution continuum, and these are the frequencies, midpoints, relative frequencies. So now the calculations have been taken off, and the data looks like this. So our interpretation would be that, so there are several patterns in the data set. For instance, the most common time span that users spent online was between 31 to 42 minutes. So this is our answer to our question. Thank you very much. Okay, so now we move on to question number 30. The data collected on religion from census reports are, the options are primary data, the secondary data, sample data, or A, which is primary data, or B, which is secondary data. So the question says data collected on religion from a census report. Is it a primary data, secondary data, or a sample data, or A or B? Now, first of all, we must know what is a primary or a secondary data. So we can classify the data either as primary or secondary. The data which are collected for the first time by any investigator or any agency are known as primary data. Whereas data that are known to be secondary if the data has been already collected and are used by different persons or agency. So let's look at this. So we'll find that data collected on religion from a census report. That means it is a secondary data. So we have collected the data from a census report. So somebody collected the census report data, and then we found the religion from the census report. So it will fit in as a secondary data. Now, there are various sources of secondary data, which are, you see, like we can get the secondary data either from WHO report, or international labor organizations, or IMF, International Monetary Fund, or World Bank, or we can take a government source like CSO, okay, or Indian Agriculture Statistics by the Ministry of Food and Agriculture, or we can have data from a private source like NCRT, ICAR. So these are the various sources from which we get the data, secondary data, and we can use all these data published by these very agencies and many more, and then we can make an analysis out of that. So we data collected on religion from the census is a secondary data, so it fits into a secondary data. So we are using the data from the data available from various sources, and then we are analyzing with regard to religion. So let's do question number 31. The data collected on height of a group of students after recording their heights and measuring tape are primary data, secondary data, discrete data, and continuous data. So data collected on the height of group of students after recording their heights with a measuring tape. Now, this is basically an example of a primary data, because somebody is collecting the data on the basis of height of group of students, and then they are recording the heights with a measuring tape. So this is a example of a primary data. The first time the data is collected with a sample of the group of students. So this will form as a primary data and not a secondary data. Now, question number 32. The primary data are collected by interview method, observation method, questionnaire method, all of this. Now, primary data can be collected by using all of these. So whenever we want to collect a primary data, we can either interview people, or we can observe and find out the data, or we can float a questionnaire. So these are all sources of primary data for collecting the primary data. So our answer or option would be all of this. So let's do question number 33. Represent the following production cost of sugar in a certain week under different heads in a sugar factory by a pie chart. Now, pie chart is a graphical representation of data, tabular data. First, we make a tabular data and then convert that into a pie chart, which gives a bird eye view of the data, and we can make analysis out of that. So the raw material is 192. The figures are production cost is in thousands. So it is 1,92,000. Then labor is 153.6. Direct production is 57.6, and other cost of other material is 76.8. So this is the data which is given, and we are required to find a pie. We are required to make a pie chart. So first, we are going to put this data in a tabular form. So we know that the raw material is one element of cost, and production cost is 192. So what we'll do, we'll take 192 and divide this by the overall number, which is 480, the overall cost. Then multiply this by a 360 degree, because in a pie chart, the data is represented in a 360 degree format. So we'll find a central angle for this. So this will come as 144 degree. So similarly, we can do for labor also. So labor is 153.6. We will divide by the total cost, which is 480, multiplied by 360. So this is simply a calculation which we are doing, workings. So this will come to figure of 43.2 degree. Then we can do it for 57.6 also. 57.6 divided by 480 into 360 degrees. So this will be 57.6 degree. And finally, we can do for other costs. The source is others here, so which is 76.8 divided by 480. That is the total cost of production into 360 degrees. So here we have rather this is 57.6. So beg your pardon. There were some corrections there. This is 115 degree, and this is 43.2 degree. So these are wrongly written. So this is, so we find 144 degree here, 115.2 degree. Then we have 43.2. Then we have 57.6 degree. So now we have the information which is there for making a pie chart. So our next step would be to make a pie chart. So this is a graphical representation of data in pie chart form. So we first look at the raw material, which is, we'll use a D or a geometrical instrument, and we'll see this is around 144 degree, which we calculated. Then we look at the labor, which is 115.2 degree. Then we have direct production, which is 43.2 degree. And others are 57.6 degree. We can always also represent data in terms of percentage of the circle. So this is raw material is 40% of the cost, whereas labor is 32%, others is 16%, and production cost is 12%. This is a pie chart showing the cost of sugar. So we can now see that the raw material constitutes the maximum cost, which is about 40%, and then labor is the second big component, which is 32%, and then we have others, which are 16% of the cost, and direct production is 12% of the cost. So this is how the pie chart looks. So we'll now solve another question, question number 34. Following data gives the student strength of a college in a different years. Represent the data by a percentage bars. So we'll make a percentage bars out of this data. So there are various colleges: College A, College B, College C, College D, and College E. So in College A, we have 1,200 boys and 800 girls, and the total strength of the student is 2,000. In College B, there are 1,300 boys and 1,300 girls, so the overall strength of the college is 2,600. And College C, there are 1,350 boys and 1,650 girls. So the overall strength is 3,000. And B, there are 1,440 boys and 2,160 girls. So overall strength is 3,600. For E, there are 1,600 boys and 2,400 girls. So overall strength is 4,000. Now we have to represent this data by a percentage bars. So what we'll do, we will now solve this question. So we'll put this in a tabular form using the data points given in our question. So we know, of course, total is already given. So I'm going to just re-put this data again. So the total strength of various colleges is 2,000, 2,600, 3,000, 3,600, and 4,000. So now we calculate the percentage of boys. So which is 1,200 divided by 2,000 multiplied by 100. So we get 60%. So 60% are boys. So that means the remaining will be girls, which is 40%. And similarly, we can calculate the percentage of boys and girls for college B also. So here it is 1,300, 1,300. So it is 50%. Pretty simple. And here it is 1,350 and 1,650. When we calculate, we find 45% are boys and 55% are girls. So here it is 1,440 and 2,160. When we calculate, it will be 40% boys and 60% girls. So this also is the same, 40% boys and 60% girls. So now we have this information in percentage. So we can make a percentage bars. So we'll now make a diagram like this. So if you look, this is data presented by percentage bars. So we have college A, college B, college C, college D, and college E. So here we'll have the percentages put. So all will be falling within 100%. So in the first college, we found that 40% are girls and 60% are boys. So 60% boys, which is here, and 40% girls. So we can make a percentage bar, and which will represent the 60% are boys and 40% girls. So in second college, there are 50% boys and 50% girls. So we can make a percentage bar, which can represent like this. So similarly for college C, the number of boys and girls percentages are there, 45% boys and 55% girls. So here 40%, 60% girls, 60% girls. Okay. So here also. So we find that in most of the colleges, the number of girls are more. So college D girls are more, college E girls are more. And then we have in this college also 55% are girls. And this represents their equal set of students, 50-50. But in this college, the number of boys outnumber the girls. So this gives you a pictorial graph of the number of students between girls and boys and representing their percentages. So this is a data which represents the percentage bars. So let's understand question number 35. A sample of 100 apples from an orchard on weighing gave the following results. So these are the weight of apples, and these are the number of apples, 100 apples. So the first class interval is that between 100 to 120 grams, there are 4 apples. Between 120 to 140 grams, there are 6 apples. Between 140 to 160, there are 27 apples. And between 160 to 180, there are 34 apples. And between 180 to 200, there are 20 apples. Between 200 to 220, there are 6 apples. And these are large size apples. Between 220 to 240, there are only 3 apples. So overall, there are 100 apples. So we have to draw a frequency curve for the distribution. So now we are going to make a frequency curve. So we can write a frequency curve of weight of apples. So what we'll do, we'll make a graph like this, and we'll try to make a frequency curve of this graph. So what we'll do, we will on this axis, we are going to have the number of apples. So here it will be number of apples. Okay, and this will be the weight. The weight has been given, so we are going to put the weight in grams here. So now we are going to plot this. So how do we do is that we know that first we'll write the data here. So this is between 100 to 120. There were 4 apples. So I'm just taking the figure from my question. So this is between 120 to 140. There are 6 apples. And between 140 to 160, then I'll just first put all these things so that I don't miss out anything. 160 to 180. Then we have 180 to 200. Then we have 200 to 220. Then we have 220 to 240. And the corresponding frequencies or number of apples are 4, 6, 27, 34, 20, 6, and 3. Altogether, it's 100. So there are 100 apples weighing between this. So we will just take the midpoint out of this. So this will be 110. The midpoint here is 130. The midpoint is 150. So this will be 170. This will be 190. This will be 210. This will be 230. So now we are going to plot. So I just break this. So this is like this is the break. So this starts with, say, first figure is say 90. Then I add up and make first as 110. Then this would be 130. So I'm just plotting the midpoints here. 130. So this is this. So this is 140, rather 150. This will be 170. So this will be 190. And this will be 210. This will be 230. And this will be 250. So now we can plot. So at 110, which is a midpoint, there are 4 apples. So the here also I'm going to put numbers. 0, let's take an interval of 5. So this is 10. This is 15. This is 20. Then we have 25. And then finally we can have 30 and another one as 35. So now we look at 110 and see there are 4 such points. So 110 we can have a point maker here below 5. Then we have between that 130 there are 6. So 130 there are 6. So right here it will be somewhere. Then we have 150 which is 27. So 150 goes right up to this. So there are 27. And then we have 170 which goes to 34. So it will be somewhere here. Then we have 190 which is 20. So it will be coming here, somewhere here. Then we have 210 which comes right here, somewhere 6 here. And then we have 230 which is 3. So it will fall somewhere here. So now we are going to make a curve. So what we'll do, we'll just make 2 extended points, 90 and 250, and make a smooth curve. And join at 250. So this is a frequency curve of weight of apples. So this is the frequency curve we have made, and we were required to make a frequency curve of weight of apples. So this solves our question. So let's look at question number 36. The following data represents the ages of 30 students in a statistic class. Construct a frequency distribution that has 5 classes. So this is the age of students we have. So these are the data which were given, 30 students. So find out the class mark, which is also called midpoint, a relative frequency, cumulative frequency, and draw a histogram, a frequency polygon, and ogive. So let's solve this question now. So let's now solve the problem. So we'll do some working before we come out with all the solutions. So number of classes 5, which is stated in the question itself or in the problem. Then this is the first. The second would be that the minimum data entry, which we noticed in our data, is 18, and the maximum entry which we noticed is 54. So the range is 36. That's the difference between 54 and 18. So the range is 36. Now what we're going to do is we are going to divide the range by the number of classes, the number of classes, to find the class width, to find the class width. Sorry, this is width. So the class width would then be the class width will be equal to the range, which is 36, divided by the number of classes, which is 5. So we got 36 and 5. We are using this data. So we get 7.2. Now this should be rounded up to 8, the next number. So this is rounded up to 8. So this is the first step. So now we are going to find the lower class limits and upper class limits. So the next step is to find out the lower class limits. The lower class limit would be, the starting point is the minimum data entry is 18. So that will be used for lower limit of the first class. So to find the lower class limit for the remaining classes, we will add 8, which is the width to each lower limit. So that means it will be, next lower limit will be 26. Then the subsequent will be 34. So we are going to add 8 and 50. So this is the lower class limits. Then we can also find the upper class limits also. Which will be 25. So this is 26. So minus 1 is 25. So this is 34. 1 less than this, 33. Similarly, 42. 1 less than this, it will be 41. And then 49. Okay. And 57. The finally will be 57. So now what we are going to do is, now we are going to make a frequency. We are going to identify each frequency in each distribution table, and we will solve this problem. So we'll put the data like this. So we have now the class intervals, which we computed in our last slide. So the upper limit and the lower limit we have found. So now we are going to identify how many students fall under each category. So looking at the data, we find there are 13 students. So we will make a tally marks for each data and then try to find out how many students fall under this category. So we find that there are 13 students which are coming in this class interval. So these are ages, and these are the number of students. And then we have between 26 to 33, we find that there are 1, 2, 3, 4, 5, and then there are 3 more sitting in this data. So there are 8 number of students which are coming in this class interval. So between 34 to 41, we find that there are only 4 students. And between 40 to 49, we found that there are only 3 students. And between 50 to 57, we found there are only 2 students. So this will be a sum of all the frequency, which will come as 30. So when we add this up all, we get 30 here. And the data also shows that there are, the data represents ages of 30 students. So to find out whether we have got the arithmetical accuracy, by just simply adding, it should be equivalent to 30. So now we are going to find the midpoint. So the midpoint of a class is the sum of lower and upper class limits of the class and divided by 2. So midpoint is sometimes also called the class mark. And the formula would be midpoint is lower class limit plus the upper class limit divided by 2. So we can now easily find the midpoints. So we look at the frequency first, which is already we have calculated. So we are going to just put the numbers here. And the midpoint would be 18 plus 25. That is the lower class limit plus the upper class limit divided by 2. So this will come as 21.5. So though we are required to find the midpoint, but its ultimate use will be when we make a histogram. So this is 8. So this is 26 plus 33 divided by 2. So we will get 29.5. Similarly, we will be getting, this will be 34 plus 41. This will be divided by 2, so we will get 37.5. And so this will be 42 plus 49 divided by 2. So we will get this as equal to 45.5. And we can also calculate this 50 plus 57 divided by 2. So we will get for this also. So this will be 53.5. So now we have to find the relative frequency. So first of all, we must know what is the relative frequency. The relative frequency, so I'm going to put the word RF for relative frequency, of a class is the portion or percentage of the data that falls in that class. So to find out the relative frequency, of a class, we divide the frequency, which we can write as F by the sample size. Which we can write this as N. So that means the formula of relative frequency that can be put in short as class frequency divided by sample size. So we can just put as F divided by N, where F represents the class frequency and N as the sample size. So now we can find out the relative frequencies for the age of students. Now we have 13 number here, we have 8 here, 4 here, 3 here, and 2 here. So what we are going to do is we are going to take the figure 13 and divide this by 30. This is the sum of frequencies. So we are going to take 13 divided by 30, and we have the relative frequency as 0.433. Then we can do for the second one, which will be 8 divided by 30, so which will be nothing but 0.267. So this relative frequency is nothing but portion of students. So this is 8. So this is 4. 4 divided by 30. So this will be 0.133. And this will be 3 divided by 30. So which will be 0.1. And this we can take as 2, which is the frequency, 2 divided by the total frequency 30. So this is going to be 0.067. So here we have found the relative frequencies for the age of students. So which is 0.433, 0.267, 0.133, 0.1, and 0.067. So now let's find out the cumulative frequencies for the age of students. The next was the cumulative frequencies. So we know that the frequencies are 13, 8, 4, 3, 2, and the sum is 30. So this is a pretty simple exercise where we take the cumulative frequency as 13 for the first, then we're going to add 8 to this, so this comes to 21. So 21 plus 4, which comes to 25. There we are going to take 25 plus 3, which is 28. Then we're going to take 28 plus 2, so this comes to 30. So this matches with our overall frequency. So this is the cumulative frequency for the age of students. So this solves our problem up to this stage. So let's move on to find out what is a frequency histogram first. So we are going to draw a frequency histogram. So a frequency histogram is a bar graph that represents the frequency distribution of a data set. Now there are 3 steps. First, the horizontal scale is the quantitative and measures the data values. So on the horizontal axis, which will represent the data values, and the vertical scale measures the frequencies of the class. And remember, very important point, that consecutive bars must touch each other. So now what we are going to do, because we are making a frequency histogram, so we must find the class boundaries. So we know the frequencies are 13, 8, 4, 3, and 2. And overall total is frequency is 30. So cumulative frequencies is 30. So let's find the class boundaries. We'll use our knowledge of earlier questions where we found the class boundary. We know that the lower class boundary, the formula is LCL, that is the lower class limit, minus B upon 2. And the formula for upper class boundary is UCL, which is upper class limit, plus D divided by 2. Where D is the difference between the lower class limit of the next class, which is this lower class limit of the next class, and upper class limit of the given class. So we are going to focus on this. So what we are going to do is, we are going to take the lower class limit, which is 18, minus D, which is 26 minus 25, divided by 2. So we get 17.5. And this, if we calculate using this formula, will come to 25.5. Okay, so we can do for the rest the same thing. So upper class boundary would be what? This formula, which is the upper class limit, which is C here, upper class limit, which is which you use, and we calculate this, we'll get 25.5. So we take 25 plus 26 minus 25 divided by 2, so which will be 25.5. So we can do it for the rest as well. So this will be 25.5 minus 33.5. So this will be 33.5, 41.5, and for this it will be 41.5 to 49.5. So this will be, and this will be 49.5, and this will be 57.5. So this is the class boundaries what we have found. Okay, so let's make a frequency histogram. So what we'll do, we'll make both the axes. So this is the both axis. So we'll put the frequencies here. So we will put this as 0, this as 2, this is 4, this is 6, this is 8, this is 10, this will put as 12, and this is 14. And here we are going to put the this will represent the age in years. And remember, we made the class boundary, so we're going to use that. So the first will be, so this is a broken axis here. So this starts from the first, this is 17.5. Then we move on to, this is 25.5. This is, we'll use as 33.5. And this will take as 41.5. Then we will use this as 49.5. Then finally we will take as 57.5. So the first, the frequency was coming as 13. So this will be somewhere here. So this is 13. So we are going to make a box between the class boundaries. So this is 13. The next will be touching this, which is 8. So this is here. So this comes up to 33.5. So this is 8. Then we are going to make for this 4 also. This is frequency is 4 here, between this and this. 4. Then we have between 41 to 49 we have 3. So it will be here. And finally between 49.5 to 57.5 we have 2. Remember, we made class boundaries, and this is used for making a histogram. So this is a age of students. So between the age of 17.5 to 25.5 there are 13 students, and between 25 to 33.5 there are 8 students. Between 33 to 41.5 there are 4 students. Between 41 to 49.5 there are 3 students. And between 49.5 to 57.5 there are 2 students. So this data has been now represented into a frequency histogram. So we'll make a frequency polygon. So frequency polygon is a line graph that emphasizes the continuous change in frequencies. Change in frequencies. So this is what the frequency polygon means. So let's make a frequency polygon. So we will draw a line here. So this will represent a broken axis. So here we are going to plot the frequencies. Here we are going to plot the age in years. So here we are going to make 0, 2, like we did for a histogram. So this is 6, this is 8, this is 10, this is 12, and this will be 14. So now what we are going to do, we are going to take the midpoints, which will start from here somewhere 21.5, and we extend this to 13.5 here also. Then we are just taking the midpoints of the histogram, and this will be 37.5, this will be 45.5, this will be 53.5, and this will be, so we're going to extend one more on the x-axis to 61.5. So now we are going to plot it. So this point will be 13, as we know. This will be somewhere here. And for 29, it is represented as 9. So we are going to, I'll look at the data. So this is 8 rather, 29 is 8. And 37.5 represents 4. And then we have 45.5, which represents 3. Then 53.5 represents 2. So we are going to make a frequency polygon through a freehand curve, then like this, and then we are going to extend this and join these at this. So here the line is extended on x-axis. To the x-axis. So this is the extension part. And these are all representing the midpoints actually. So here we use those midpoints which we calculated in our earlier part of our problem. So we use the midpoints and put the frequency against those midpoints and then join those through a scale, and we get a frequency polygon. So now we are going to ultimately make a cumulative frequency graph, or it is called augur. Now it is a line graph that displays the cumulative frequencies of each class at its upper class boundary. So now let's make it. So here we will have the cumulative frequency. So this will represent a cumulative frequency, and this will represent the class bar, the same. So this will be a broken area. So this will be ages in a year. This will represent age in years as usual. Now we are going to put this as the this will be 0. This we can make it 6. This is 12. This is as 18. This is 24. And finally at 30 is the last cumulative frequency. And here I am going to use the upper class boundaries. So which is 25.5. And I can extend this to 17.5 as a starter. And then this will be 33.5. Then we have the 41.5 mark, and here it will be 49.5. And finally, we can extend this to 47.5. And now we are going to plot the cumulative frequencies. So we know that we made a cumulative frequency chart. So this was first was 13, so which was 13. So we are going to use that figure for making our cumulative frequency graph. So this will be 13 here, and then at 33.5 it will be 21. So this will be 21, and then we have here as 25, and here we will be having as 28. and this will be 30. So now we have made a cumulative frequency graph or OGIF. So we are going to join. So we start from here and make a OGIF. So the graph ends at the upper class boundary. Ends at the upper boundary of the last class. Remember, we have displayed the cumulative frequency at each class at its upper class boundary. At its upper class boundary. So these are the upper class boundaries. So we have represented the frequency at this class, and the corresponding frequencies we can just put here as 13 here. Then it goes to 21. Then it is just 25. Then 28, and then finally 30. So this is a cumulative frequency graph, or called OGIF. So that solves our question. Thank you.